Now come to the next circuit. This circuit is already in simplified form. In this circuit we have three resistors, a practical cell having EMF of 2 volt and internal resistance of 3 ohm. Okay, and there is an ammeter connected in the circuit reading the current 0.25 ampere. This ammeter is connected just to the left of this cell, and this current read by this ammeter is the current drawn from the cell. Okay, so one important thing is the ammeter reading reads the current drawn from the cell, that is I. And we have one unknown resistor R having resistance R, and two known resistance 2 ohm and 4 ohm. Unknown resistance is connected in parallel with 2 ohm, and this parallel circuit or combination is connected in series with 4 ohm and 3 ohm. Okay, 4, 3 and this parallel combination are connected in series. Now execute step 1. First find the equivalent resistance of the circuit. Okay, here the two resistors are connected in parallel, so find the parallel combination of these two. So the parallel combination of these two is Req. 1 upon Req is equals to 1 upon 2 and plus 1 upon R, and this would be R plus 2 upon 2R. When you reciprocal the whole term, then you get Req is equals to 2R upon R plus 2. Okay, so this is the equivalent resistance of this parallel network. Okay, parallel network. So now this parallel network 4 ohm and 3 ohm are connected in series, so all the resistances are added. So the total equivalent resistance of the circuit will be this 2R upon R plus 2 plus 4 and plus 3, and this comes out to be 2R upon R plus 2 and plus 7. So this is the total equivalent resistance of the circuit, and EMF of the cell is 2 volt. Okay, and the current drawn from the cell is 0.25 ampere. Now apply Ohm's law at the circuit level. We have I is equals to E upon Req. Then we can also write Req is equals to E divided by I. Okay, so E is 2 divided by 0.25, and Req would be equals to 8. Okay, 8 ohm. But Req is equal to this term, so we can put the value of Req here. You get 2R divided by R plus 2 and plus 7 is equals to 8. When you solve it, you get 2R upon R plus 2 is equals to 1. Okay. When you rearrange, you will get R is equals to 2 ohm. Okay, R is equals to 2 ohm. Is it clear? So note it down. So the unknown resistance, the value of unknown resistance is 2 ohm. Now find the potential difference across the internal resistance. Okay. So the current drawn from the cell is 0.25 ampere, which is flowing through the circuit. At this point, this current I is divided into two parts, say I1 and I2. Okay, and these two currents recombine here at this point and produce the current I, which is 0.25 ampere. And this current flows through 4 ohm as well as 3 ohm resistance. Okay. Okay. Same current will flow through the 3 ohm resistance. Now we know for this internal resistance, the current I, which is equals to 0.25 ampere, is flowing through the resistance, and the value of resistance is 3 ohm. So apply Ohm's law for this element. When you apply Ohm's law for this element, you get V4 is equals to I into R. So I into 3. Okay. The value of I is 0.25. So 0.25 into 3. Then you will get 3 by 4. Okay. Or 0.75 volt. Okay. 25 3 is a 75. 0.75 volt. So the potential difference across this internal resistance is 0.75 volt. Okay. Now, what is the value of V3? What is the potential difference across 4 ohm resistance? Same way we can solve V3. Apply Ohm's law for this element. The current I into the resistance 4. Okay. I is equals to 0.25 into 4 will be equals to 1 volt. So this is equal to 1 volt. Okay. Now 2 volt is the supply voltage, out of which 0.75 appear here and 1 volt appears here across 4 ohm. Now what is the remaining voltage left? So 2 minus 1.75, that is 0.25. So 0.25 appear here. This is the parallel network. So V2 will be equals to 0.25 volt and V1 also equal to 0.25 volt. Okay, both will be at same potential because both are connected in parallel. And why the potential difference is 0.25? Because out of 2 volt, 0.75 appears across 3 ohm and 1 volt appears across 4 ohm, and remaining 0.25 must appear across this. Okay. So this is 0.25 and this is also 0.25. Now we can calculate I1 and I2 by applying Ohm's law for these two elements. Now write I1 is equals to, for this element write Ohm's law, I1 is equals to V1 upon R1, R1 is 2 ohm, V1 is equals to how much? 0.25 upon 2, 1 by 8, okay, ampere. And same current I2 is equals to 0.25 upon 2 is 1 by 8 ampere. Okay. So the same current will be in the two branches. Okay. So note it down. So it is clear from this calculation that when resistances are equal in parallel circuit, when resistances are equal, then current divides equally. See, I1 is equals to 1 by 8, I2 is equals to 1 by 8. Why? Because the resistances are equal in the parallel circuit. Okay, so this point is to be noted that in parallel circuit, when resistances are equal, then the current divides equally. Okay, note it down.